Welcome to topic 2. I've had a look at the slides and I've decided that I'm not going to bore you by droning on and on through those slides, as they've got some examples that you can work through. So what I want to do is basically get across as intuitively as possible the 7 key concepts that are in those slides. And then once you've had a look at this presentation or listen to it, I suggest you have a look through the slides and try to work through some of the worked examples there. And if you have problems with them, hey, go onto slack.com and just have a chat with me. And if there are problems that are reasonably common, then I'll just record some videos and we'll talk our way through those. So let's get started. First thing I want to talk about is the time value of money. I mean, that's basically this week's topic. So rather than whipping through these slides, I want you to think about something like this example that they have there. And I'm going to duck across to Excel to try to illustrate to you the way that I would normally illustrate to my students. Because PowerPoints are a little bit of a straitjacket sometimes. So what I want you to think about is 2 dates, today and someday in the future. Let's call it, just to keep it simple, let's call it a year in the future. Okay, and today you've got $1. Now, I'm going to ask you the question, if I gave you a choice between $1 now and $1 a year from now, which would you choose? And there are many reasons why, hopefully, you're going to say $1 today. And those reasons, let's start with the basics. If you believe that inflation exists, well, these days I'm not so sure, then having $1 now means it is simply worth more. $1 a year from now will buy you less than $1 will buy you now. Okay, if inflation is important to you, yeah, that's something you think about. But there are 2 other reasons why this time value of money concept is important, and inflation might only be one. So we've got this. Most of you would agree that $1 today is better than $1, a year away. Okay, there might be other reasons other than inflation. For example, if I basically said to you, hey, how about I'll lend you $1 today for a certain percentage return, would you borrow it? Well, if I lend you $1 and I charge you 10%, would you borrow that? How much are you going to have to repay a year from now? At 10%, you're going to have to repay $1.10. So if you're looking at some project to invest in and your cost of borrowing is 10%, you would not invest $1 in a project unless that project was going to be worth at least $1.10 down the track, right? You need the 10 cents there in order to cover the interest. So if it's worth $1.10, you sort of don't care. You're indifferent. If it's worth less than $1.10, you do care. You don't want the project, because if it makes you 5 cents but you're paying 10 cents interest, yeah, that's a way of going backwards pretty quickly. On the other hand, if it's worth $1.15 a year from now, but your loan is worth $1.10, the dollar you borrowed plus 10 cents interest, then the project is worth going for. So the rate at which you borrow money is relevant for you making this comparison between now and the future. If you can get a project that you can invest in $1 now, but it gives you $1.20 down the track, $1.20 down the track is worth more to you than $1 now. Because if you don't have that dollar, it only costs you to get into the project. It only costs you $1.10. Borrow the dollar, repay the dollar with 10 cents interest down the track from your $1.20 investment, and you're ahead. So let's just come back to this comparison. $1 today is certainly worth more than $1 in future. What about $1 today and, let's make it interesting, $100 in future? I don't think you need much of a brain to say, hey, $100 a year from now is certainly a lot better, right? Because if I've got $1 today, there's not a lot that I can do with that dollar that will turn it into $100 for a reasonable level of risk. So, if I get the choice of taking $1 today or $100 a year from now, I'll take $100. So notice that what we've got is we've got 2 situations where it's quite clear which we prefer. Somewhere in the middle between these two there's going to be a point at which you're indifferent. Right? Now, that indifference point is going to be different for everybody. It might depend on your views about inflation. It might depend on your views about risk. It might depend on how much you can borrow for. And if you're high risk, it might cost you 10% a year to borrow. Somebody else who's low risk might cost 5% to borrow. So it's going to depend on your cost of funds. So, if your cost of funds is $1.10, then you're going to be indifferent between something that's $1 now and $1.10 a year from now. Because if you borrow $1, it costs you 10 cents to borrow. The project gives you $1.10, pays off your loan, you're still back at zero. Okay, so that indifference point for you is an indifference point where the discount rate is 10%. Let me explain that concept of discount rate. The discount rate is, take that future dollar, right? What do you have to divide it by to come up with $1 today? And the answer in this case, we know, is $1.10, right? So divide by 1.1. That's 1 plus an interest rate of 10%. Okay, so if I divide $1.10 by that, $1.10 divided by 1.1 gives me 1. Right. Okay, so you will be indifferent at a different point than somebody else, but there will be a point of indifference. And that point of difference is your discount or interest rate. Okay, we can call it an interest rate if the thing that you're worried about is borrowing, but if you're not worried about borrowing, if you're worried about risk or other things, a more general term is the discount rate. Okay, so that's the time value of money. Briefly, what does that mean? It allows you to make choices between somebody giving you $1 now, somebody giving you a different amount at some stage in the future. It also allows you to compare between different investment opportunities. But let's not get ahead of ourselves. That's a few topics down the track. Let's focus back in on the basics. So if I know how a discount rate relates a future dollar to today's dollar, I can actually turn all future dollars into present dollars and make direct comparisons. I can also calculate how much I need to put aside for if I need a certain amount of money in future. Or even more simply, I can work out how much I can afford to borrow. So let's look at that last one. Let's look at how much I can afford to borrow. I know that if I borrow an amount, I've got some opening balance, that's the amount I've borrowed. What's going to happen to that borrowed amount each year? Two things are going to happen. Firstly, some interest is going to be added on. So if my interest rate is I, it's going to be multiplied by 1 plus I. What's the other thing that usually happens with loans? You have to make repayments as you go, right? So a payment is going to come off. Oh, sorry about that. A payment is going to come off. And that's going to give you whatever the closing balance is at the end of the first year. Now, let's actually run this forward for 2 years. Okay, so let's look at how you would work out what a loan for 2 years looks like. You know that the closing balance is just what we started with, the opening balance, times 1 plus I minus P, right? But what happens in the second year? Well, in the second year, the opening balance is basically that closing balance at the end of the first year. I mean, this is the last day of year 1, and the balance on the next day of year 2 is essentially the same. Okay, so that's your starting balance. Now, what's going to happen in the second year? Same stuff that happened in the first year. You're going to add interest, so you're going to multiply it by 1 plus the interest rate, and you're going to take off another payment, right? So, but let's say it's a 2-year loan, right? At the end of 2 years, you want all of this to have the loan repaid. There are 2 payments, loan's repaid, you want the closing balance to be 0. So what do we know? We know what P is, or we can work it out. Basically, we've got 3 things we can possibly know or work out. X, the amount you borrowed, I, the interest rate, and P, the payment that you make. So let's basically take this last year and rearrange it using some high school maths, if you remember that. we've got the opening balance, right? Let's stick some brackets around that just to make it clear. We multiply that by 1 plus I. We take off P, and that gives us a zero balance. Now, we can rearrange that. And I'm not going to rearrange it step by step for you. Trust me on this. That you can rearrange it to give you X equals payment at the end of year 1 divided by 1 plus I plus payment, same payments are identical each year, at the end of year 2 divided by 1 plus I squared. Now that simple formula actually tells you a lot and lets you work out a lot. X, the amount you borrow, is the present value of these payments that are going to be made. Right, so previously, we talked about having a present value today and a future value, which is the amount something was worth a year down the track, or 2 years down the track, or 5 years down the track. What we've got here instead is a present value today, the amount you borrow, and it's meant to be equal to the value of all the payments that are going to be made in future, but brought back into present dollars. See, we're dividing the one that's 1 period away, we're dividing by 1 plus I. The one that's 2 periods away, we're dividing by 1 plus I squared. And, logically, you can actually extend this. If this was a loan that went for 20 periods, your last, and all the repayments were the same, the last payment would be 1 plus I to the power of n, where if it's 20 periods, that would be 20. But let's keep it simple. Let's go back to just a 2-period loan. Sorry about that. What can you tell from this? You can actually do a lot of stuff with this. You can say, hey, look, I can afford to make repayments of P. Bank is charging me an interest rate of I. How much do you think they'll lend me? Well, if you know how many repayments you can afford to make P, and you know what I is, then you can work out what X is. Alternatively, from the bank's perspective, they would say, hey, look, this guy's coming up to us. He wants to borrow X. Our interest rate is I. Can we work out what P is? What payments would we require this guy to make? And actually, that's actually pretty easy because, again, remember your high school maths. The P appears in all of these terms. So you can take the P out outside the brackets. And can you work out P easily? Well, yes, you can. Because you can work out the 1 over 1 plus I, 1 over 1 plus I squared. So you've got everything here in the curly brackets. Right, you can work that out. You know what the guy wants to borrow, that's X. Divide X by everything in the curly brackets, and you can work out what repayment the guy can afford to make. So this present value calculation approach is actually useful in a lot of contexts. We'll be using it to make decisions further down the track where we've got payments from different projects, but those payments are different at different periods. And we want to know in today dollars, present day dollars, which project is worth more to us. But for the moment, you should be aware that the fact that $1 today is not worth $1 a year down the track or 2 years down the track, but we can actually specify what the difference is. We can specify this discount rate, this I. Using that, we can actually turn future dollars into present dollars, and we can make decisions like working out how much to borrow or how much to lend.